Alright, in this problem we have to deal with this projectile. It's launched straight up at 60 meters per second from a height of 80 meters at the edge of a sheer cliff. The projectile falls just missing the cliff and hitting the ground below. And part A, we have to find the maximum height of the projectile above the point of firing. And part B, the time it takes to hit the ground at the base of the cliff. And C, its velocity at impact. Okay, so we'll start off by drawing a picture. That's always a good idea, or maybe not always, but it usually is. Here's our cliff. Well, here's our cliff. Maybe that's a little wrong. It's probably a little jagged too. Anyways, so then the projectile is launched at the edge of this cliff. So let's say this is where it's launched. And it's going to go something like this. So this is the initial position where it starts. This will be the max height, or the vertex of this parabola, as you can already tell. And I'm just putting other points to make it more easy to work with. So let's identify what we have. So we are told that it's launched straight up at 60 meters per second. So 60 meters per second is our initial velocity. So let's put that over here. Our initial velocity is 60 meters per second. Whoops. Right. Fan is buzzing all weird. Okay, the projectile is launched straight up at 60 meters per second from a height of 80 meters. So 80 meters is going to be the initial position. So why not 80 meters? So then this will be where t is 0 and where y naught is 80. And I guess so that means this height right here is 80. This length is 80 meters. I love whiteboards. They're so cool. Okay, next part. So we have to find the maximum height of the projectile. We got to find what this value is. We want to find what the t value is, and what the y value is. We'll call it y max. Now, for that, we have some equations. These equations are given on your exam. It's on a formula sheet, along with like another 100. So just make sure you know how to use them because they're very useful. So at the vertex, or at the max height, the velocity is going to be 0 because it's going to basically not be moving. It's going to be frozen for an instant in time, we say. So the velocity will set equal to 0. So v equals 0. And from here, we just solve. So we have 0 equals the initial velocity we have is 60 plus the acceleration. And remember, for gravity or for projectiles, it's under the influence of gravity. So that means that we're going to have an acceleration of negative 9.8 meters per second squared. That's usually what we're going to use as the standard approximation. So we're going to have negative 9.8. Well, this will not be units, negative 9.8 t. And let me put it to the side in case you need it. A equals negative 9.8 meters per second squared. And let's solve this. So we're going to have, solving this, and we'll get t will be, let's use a calculator. So 60 divided by 9.8. So 6.12. So at the top, it takes 6.12 seconds to reach that. And color, but it's fine. It's all good. And so to find the y value, or the maximum, we can just plug 6.12 into our equation for position. It doesn't matter that it's x. X is just a letter, as you know, but you can call it y. It just matters if this equation gives you position. So instead of x, we're going to y. So y is equal to y naught, or 8, which is 80. Why is that thing? Well, actually, let's put 80 times 0. So y naught, v naught, initial velocity, 60 t plus 1/2 a, which is negative 9.8 t squared. Right. We got some math going. So we just have to solve this. Oh yeah, that well. Let's solve this for plugging t in at 6.12. So I'll just write it over because I like writing. Who doesn't like writing? Well, I mean, I like writing on my face. 60. Switch with the red. 6.12. Plus, let's go minus 4.9. Some math. Times t squared. So negative, or no, 6.12 squared. And now it's Mr. Texas Instruments calculators time. So we got 80 plus 60 times 6.12 times 4.9 times 6.12 squared. 263.67 are significant. We have 3 significant digits, so we're going to go to 264. 264 meters. All right, so that's the highest point. Now, I think it says above the point. It says the highest or the maximum height above the point of firing. So then you technically would look from 80 to 264, and that would be 184. So this would be, our answer would technically be 184 if you have like a stingy or stick grader or something, or if it's like a multiple choice, pick the 184. Now, so what we got now? So the time it takes to hit the ground at the base of the cliff. So we want to know what the time here is. We'll call that TF. And we also want to find the velocity, or velocity at that here. So we'll find VF. Big parentheses. All right. So for that, we just gotta. Oh yeah, we just gotta use the quadratic formula. We could, and not which I'm going to do. So let's remember what it is. So we typically learn it in terms of x. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And let me just write it out in case you need a refresher. That's for equations. It's for quadratic equation form. Ax squared plus bx plus c. Make sure you are comfortable with this, because you need to know this and master it just to have a chance to survive in this class. So yeah. So let's use this to solve this. So what we have is our A is the negative 4.9. Well, let me not confuse. Let me just go through it. I think you guys don't need to be this tedious. So solving for t equals negative b, so negative 60, plus or minus the square root of b squared, so 60 squared, minus 4 times a, which is negative 4.9, AC, C is 80. I don't know why I switched to that there. All over 2a, so 2 times negative 4.9. All right, now we just do some calculations. So calculated. Just so he doesn't get bored. So we have 60 squared plus 4 times 4.9 times 80, 5168, square rooted, 71.9, negative 60 plus minus 71.9, negative 9.8. This gives me, we technically get two roots. I'll write them both, but one of them is going to be negative, and we, can't go and have a negative time, at least not yet. We haven't learned how to go back in time yet. So we get two answers. One that is 13.5, and the other would be 1.2 or 1.21 using the significant digits. It's red, fine. Okay, so yeah, and that's what this is going to be. This will be your answer. 13.5 seconds. And our velocity, then, we just plug this 13.5 into our velocity equation, which is, okay, I wrote it, yeah, it's right here. Let me write it again. V equals 60 plus or minus 9.8 times 13.5. Oh, no, I have another one. Now, velocity of impact will be 60 minus 9.8. Negative 72.3. Negative 72.3 meters per second. Right. So negative 72. What's up? But all right. There we go. So hope that helps. Let me know if it does, or if I need to improve and work on my teaching. But yeah, feedback is always helpful. So just again, let me know, and I'll see you guys next time.